Scientists just found a physical barrier at the edge of the universe. And nobody is talking about it. For centuries, the math was simple. Space is infinite. It goes on forever in every direction. But new data from the James Webb Telescope suggests we are actually living inside a cosmic cage. If this boundary is real, it doesn't just rewrite physics. It means something put us here. And whatever is on the other side is trying to get in. This isn't science fiction. This is the cosmic horizon problem, and it's keeping astronomers awake at night. Because every time we look deeper into the void, we find things that shouldn't exist. Structures too big for the Big Bang, temperatures too cold for physics, and a flow dragging us away. Imagine walking through an endless desert, only to suddenly hit a glass wall. That is what the data is showing us. We have found the end of the line. But if there is an edge, what lies beyond it? Nothing. Or everything. Welcome to the edge of reality. To understand why this is terrifying, you first have to understand the golden rule of cosmology. The cosmological principle. It states that the universe is isotropic and homogeneous. Fancy words that mean no matter where you look, everything should look basically the same. There are no edges, no centers, just an endless, smooth soup of galaxies. This principle is the foundation of the Big Bang. If it's wrong, our math shatters. For decades, the data supported this. The cosmic microwave background, the afterglow of creation looked smooth. We were comfortable. We were safe in our infinite, uniform bubble. Then came the 2000s. Satellites began mapping the sky in higher resolution, and they found a bruise. They called it the cold spot, a massive region of space that was far too cold and far too empty. According to the Standard Model, the chances of this spot existing are less than 1%. Scientists panicked. They claimed it was a sensor error, a smudge on the lens, dust. But then, we launched the Planck satellite. Better eyes, better sensors. Planck looked at the cold spot again, and it didn't disappear. It got sharper. It got deeper. It was a 1.8 billion light-year-wide hole in reality. You cannot explain this with standard physics. You can't just have a hole that big by accident. Something pushed the matter away. Or, something collided with us. Enter Dr. R. Brent Tully and his team. While others looked at the light, they looked at the motion. They realized that galaxies aren't just sitting there. They are flowing like a river. Gravity pulls galaxies together. So, by tracking the flow, you can find the heaviest objects in space. They mapped 8,000 galaxies, and they found we belong to a supercluster called Laniakea. It means immeasurable heaven. It's beautiful. But then, they looked at what was pulling Laniakea. Our entire supercluster is moving at 600 kilometers per second toward nothing. They called it the Great Attractor, a gravity anomaly millions of times heavier than our sun. But here's the catch. The Great Attractor isn't strong enough to explain the speed. We are moving too fast. Something behind the Great Attractor is pulling us even harder. They called this the dark flow, and it seems to originate from beyond the observable horizon. Imagine a drain in a bathtub. All the water swirls toward it. We are in that swirl, but the drain is outside the tub. This violates every rule of cosmology. Nothing outside our universe should be able to touch us. Unless the universe isn't what we think it is. Unless it has an edge. To verify this, we needed a map of the early universe. We needed to see the walls of the structure. So astronomers mapped the Hercules Corona Borealis Great Wall, a structure of galaxies 10 billion light-years long. It is the biggest thing in existence. It is so big, light takes 10 billion years to cross it. It shouldn't be possible. The universe is only 13.8 billion years old. There literally wasn't enough time to build this wall. It's like finding a fully built skyscraper 10 minutes after the invention of the brick. This wall, the cold spot, the dark flow, they are all pointing to the same conclusion. The Standard Model is broken. We are missing a massive piece of the puzzle. If the universe is lopsided, if it has giant walls and holes, then Einstein's equations have a flaw. We tried to fix it with dark matter. We tried to fix it with dark energy. Patches on a leaking tire. But the tire is still flat. The dark flow is dragging us too fast for gravity to explain. NASA scientist Alexander Kashlinsky looked at the data and said, "This is not a statistical fluke. This is the moment cosmologists dread. The moment the map no longer matches the territory. If the universe has an edge, or a heavy side, then the laws of physics might change depending on where you are. Gravity might be stronger over there. Light might be slower. Atoms might not even bond. We are drifting towards a region of space where reality as we know it could simply stop working. Scientists were stuck. They needed a new theory. One that allowed for edges, collisions and unseen forces. They looked back at a controversial idea from the 1980s. Eternal inflation. The theory says the Big Bang wasn't a one-time event. It was just one pop in a boiling pot. Space is constantly expanding. But in some spots it stops expanding and forms a bubble. That's a universe. We are inside one of those bubbles. We think our bubble is the whole world. It isn't. This solves the problem. If we are just one bubble, then there are other bubbles out there. And sometimes, bubbles crash into each other. This is the multiverse collision theory, and it perfectly explains the cold spot. Imagine two soap bubbles floating in the air. When they touch, they don't pop immediately. They form a flat, circular interface. A bruise on the skin of the bubble. If you lived inside bubble A, looking up, you would see a giant, circular anomaly in your sky. Dr. Laura Mersini, Houghton calculated what this collision would look like. The math predicted a cold spot. Not just any spot. A spot in the southern hemisphere. With a specific temperature drop. When they checked the real data from the Planck satellite, it matched her prediction exactly. This suggests the cold spot is the site of a cosmic car crash. Another universe bumped into ours billions of years ago, leaving a scar that we can still see today. Let's take a breath. Because the implications of this are absolutely insane. If that cold spot is a collision, then the dark flow makes perfect sense too. Gravity leaks. It can travel across dimensions. The other universe is massive. Its gravity is reaching through the wall, pulling our galaxies towards it. We are being sucked toward the impact site, towards the edge. But here is where it gets darker. Collisions aren't always gentle. In bubble theory, a collision can destroy the bubble walls. A vacuum decay event. If that wall breaches, a bubble of true vacuum expands at the speed of light, deleting physics. You wouldn't see it coming. You'd be dead before the light of the event reached your eyes. Is the cold spot a healed scar? Or is it a cracking dam? To find out, we have to look at what separates us from them. The bulk. String theory calls this the bulk. A higher, dimensional space where our universe floats like a sheet of paper. We are stuck on the paper. We can't move off it. But the other universe is just another sheet, millimeters away. Think about that. The edge might not be billions of miles away. It could be right here. If you could move in the fourth dimension, you could reach the other universe by moving sideways. But since we can't, we only feel their gravity. A ghost pushing furniture in the room next door. This explains why gravity is so weak compared to other forces. It's the only force leaking out of the universe. We have been looking for the edge at the horizon. But the edge is everywhere. But let's go back to the cold spot. Because the Webb telescope found something else there. It found that the galaxies inside the cold spot are older than they should be. Massive, dead, red galaxies. Evolutionarily impossible for the age of our universe. Unless those galaxies didn't start in our universe. What if the cold spot isn't a bruise? What if it's a splash zone? Matter from a dying, older universe, leaking into ours through the collision point. We might be looking at alien galaxies. Not alien life. Alien matter. From a different Big Bang. This changes the definition of alien entirely. And it leads to a terrifying ethical question. If our universe is leaking gravity and receiving matter, it means we are not isolated. We are permeable. For decades, we have been blasting radio signals into the void, hoping someone hears us. If the multiverse is real, those signals aren't just traveling through our space, they might be leaking into others. We assume other universes have life. But what if they have predators? What if the dark forest is multidimensional? Stephen Hawking warned against shouting into the cosmos. He feared advanced civilizations, but he didn't imagine advanced universes. A universe with different physics could look at ours as a resource, a battery to be drained. The dark flow might not be passive gravity. It might be an active siphoning of our reality. Scientists are now debating if we should stop transmitting, if we should go dark, but it might be too late. The collision already happened. The door is already ajar. Some physicists argue we need to actively monitor the cold spot for signs of traffic. Proposals for next-gen telescopes aren't just about discovery anymore. They are about defense. We need to know if the bruise is healing, or if the infection is spreading. If the boundary fails, physics as we know it ends at the speed of light. It is the ultimate existential threat, a threat we cannot fight, only delay. But perhaps fear is the wrong reaction. Perhaps this changes everything about who we think we are. For all of human history, every time we discovered an edge, we found something new beyond it. We used to fear falling off a flat Earth. Now we fear colliding with a parallel universe. It is the same fear, the fear of not being the center of the story. The multiverse is the ultimate humiliation for humanity. We aren't special. We are a statistical accident. But flip that around. If there are infinite dead universes out there, how precious is this one? We live in a Goldilocks bubble, where gravity is just right, where atoms hold together, where life is possible. The cold spot is a graveyard, a window looking into a failed reality where stars never turned on. The edge isn't just a wall, it's the shell that protects us from the chaos of the bulk. Finding the edge doesn't trap us, it defines us. It shows us our place in the grander scheme. We are dwellers in a fragile bubble, drifting through an endless ocean of bubbles. And now that we know the ocean is there, we have to decide what to do next. Do we hide in fear? Or do we build better ships? The era of observable universe cosmology is over. The era of multiverse exploration has begun. The next decade will not be about looking. It will be about listening. Because light gets blocked by the edge. But gravity gets through. If we want to know what's on the other side, we need to hear the whispers of their gravity. We are building the tools right now to hear the collision that happened billions of years ago. Missions like LISA, a gravitational wave detector in space, could finally prove the multiverse. It won't see the cold spot. It will feel the ripples in spacetime the collision left behind. If LISA hears the specific frequency predicted by bubble collisions, it's game over for the old model. We will know for a fact that we are not alone. And then the real questions begin. Can we communicate? Can we travel there? Or are we forever trapped in our bubble? Some theoretical physicists believe that if you can manipulate energy enough, you can create a wormhole, a bridge across the bulk, a doorway out of our universe. It sounds insane. But so did flying to the moon 100 years ago. We have found the shore of the cosmic ocean. We are just learning how to build boats. The edge isn't the end. It's the beginning of a much bigger map. And whatever is out there is waiting for us. This discovery changes everything we thought we knew about reality. The multiverse is no longer just a cool idea for superhero movies. It is the leading scientific theory. Don't miss our next episode, where we dive into the technology that has potential to change humanity and the world.